Hello friends, you can log on to primeaptacademy.com to access complete free video courses. So this is the 33rd question of the coordinate geometry chapter. So the question says A, B and C are constant values, and if the graph of y is equal to ax square plus bx plus c cuts the x-axis at two distinct points, then which of the following is or are true? So first of all, I don't know anything about the signs of A, B and C. I know that they are some constant values, but it is a quadratic. So if it is a quadratic, also I don't know that can these be equal to 0 also. There is a possibility. So now over here the possibilities are that it can be a quadratic like this, or it can be a quadratic like this. Okay, in this case A is less than 0, in this case A is greater than 0. Alright. Also there is a possibility that if A is equal to 0, it becomes y is equal to bx plus c. Over here nowhere it says that, no, but it has to be a quadratic. Why? Because A cannot be 0. Because it says it cuts the x-axis at two distinct points. So if it is cutting the x-axis at two distinct points, that means it has to be a quadratic. So it is either like this or like this, the graph. Now if it is a quadratic cutting the axis at two distinct points, that means discriminant of this quadratic expression, which is ax square plus bx plus c. When I put y equal to 0, why I put y equal to 0? Because at those points it cuts the x-axis. At x-axis y is equal to 0. That means if y is equal to 0, I get two distinct values of x. That means its discriminant has to be greater than 0. So discriminant d over here is b square minus 4ac. So b square minus 4ac is greater than 0 for sure. So I say b square is greater than 4ac. Now if b square is greater than 4ac, the first option says that b is greater than 2 under root ac. So if b square is greater than 4ac, either b is greater than 2 root ac or b is smaller than minus 2 root ac. This is also possible. Okay? Because b square has to be greater than 4ac here. So if I square this, b is greater than 2 root ac is true if I take square root, but over here b can also be less than minus 2 root ac. Okay, less than minus 2 root ac. So is b always greater than 2 root ac? No, because there is also this possibility where b can be less than minus 2 root ac. So is this true always? No. So option 1 is ruled out. Now second question says there exists some real values of x such that y is negative number. So now if I look at it, this graph, the graph is like this. Over here in this region, which I am making red for the graph, in this region y will always be negative. So there will have a corresponding value of x. Let's say I pick this point over here. It will have some corresponding value of x for y to be negative. That is, this is the x corresponding value, so y is negative. So when the graph is like this, there will definitely be some values of y which are negative, which will satisfy this graph, wherein there will be some real values of x for which the graph is negative. Now in this case, when y is negative, that means the graph is like this. So if the graph is existing like this, that means there are values of x also satisfying this. So that means this option 2 is true. So option 2 is correct here, that there exists some real values of x such that y is a negative number. So here y is negative in this case, and you will find corresponding values of x. Here y is negative in this case, also you will find corresponding values of x. Now third says when x approaches infinite, y also approaches infinite. Okay, so when x approaches infinite, if the graph is like this, when x approaches infinite, like graph goes like this. So if the graph moves like this, x approaches infinite, y also approaches infinite. But here in this case, if x approaches infinite, the graph goes down like this. So as x approaches infinite, y is approaching negative infinity. Okay, so in this case, when x approaches infinite, y approaches infinite. But in this case, when x approaches infinite, y approaches negative infinite. So option 3 is also not true. So only statement 2 is the correct statement here. Okay, that's how we solve this question.